how qubits work in a quantum processor using everyday life examples. Hey, have you ever heard the term quantum computer and thought, yeah, no, that's way over my head, totally fair? But get this, you can actually understand the heart of a quantum computer, a qubit, using stuff you already know, like a coin, a cup of coffee, and a pair of gloves. Seriously, no equations, no headache. Let's break it down. Let's start with regular computers, the kind we use every day. They run on bits, little units of information that can be either 0 or 1, on or off. It's binary, simple. Imagine a light switch. It's either up or down, that's a bit. But qubits are weird. They can be 0, they can be 1, or, get this, they can be both at the same time. It's like a light switch stuck mid-air, flickering between on and off. That's a qubit in action. Now, picture this, you flip a coin. While it's spinning in the air, it's not really heads, it's not really tails, it's both. It's uncertain, it's in motion. That's called superposition. A qubit in superposition is like that coin, not fixed, not settled. It holds multiple possibilities at once. It's only when you catch the coin, when you look at it, that it becomes one or the other. Same with a qubit. The moment you measure it, the possibilities collapse into one answer, a 0 or a 1. Until then, it's riding the wave of both. Let's use coffee this time. You're holding a mug, but you can't remember if you added sugar. Right now, it both has and doesn't have sugar, at least in your mind. Then you take a sip. Boom. Mystery solved. It's sweet. That moment, when uncertainty becomes certainty, that's what measurement does in quantum computing. A qubit stays in that fuzzy in-between state until we measure it. And then, just like your coffee, it picks a side. Now let's turn it up a notch. Entanglement. This one's wild. It's super cool. Say I take 2 gloves. I put the left one in one box and the right in another. I send one box to Tokyo and the other to Paris. You open the Paris box and see a left glove. You instantly know, without opening it, that the Tokyo box has the right one. Simple, right? Well, qubits can do that too, but way more mysteriously. When 2 qubits are entangled, learning something about one instantly gives you info about the other. Even if they're light years apart, no signal, no delay, just instant knowledge. Einstein called it spooky action at a distance. And honestly, he wasn't wrong. Let's talk about how we actually use qubits to do stuff. In regular computers, we use logic gates, and or not, to manipulate bits. In quantum computers, we use quantum gates. But instead of flipping zeros to ones, we rotate qubits. We spin them, twist them in multiple dimensions. Picture a Rubik's Cube spinning in space. That's what quantum gates do. They move a qubit through complex possibilities. And by stacking these gates, just like stacking instructions, we build up powerful quantum programs. It's like programming, but the pieces dance. So what is a qubit physically? Well, there are a few different types. Some qubits are made from charged atoms, called ions. Others use superconducting loops, tiny circuits that carry current with 0 resistance. And some use particles of light, photons. But no matter the type, one thing is true. Qubits are sensitive, like crazy sensitive. To keep them stable, we have to cool them down, like all the way down. Near absolute 0, that's minus 273 degrees Celsius. That's colder than outer space. It's like building a sandcastle in a wind tunnel. Everything has to be perfectly controlled, or the quantum state falls apart. So, why go through all this effort? Because quantum computers can do things classical computers simply can't. Imagine a maze with billions of paths. A regular computer tries one path, then another, step by step. Slow, brutal. Quantum computer? It tries all the paths at once. Thanks to superposition, it can explore a massive number of options in parallel. This is what we call quantum advantage. That's why people are so excited. It could speed up drug discovery, break unbreakable codes, help model climate systems, or simulate physics at the tiniest scale. Quantum isn't just faster, it's a whole different way of thinking. Let's lock it in. Qubits are like spinning coins, sweet coffee, gloves across continents, Rubik's Cubes doing ballet, and high-tech gear frozen colder than space. If you remember those 5 ideas, you remember quantum computing. Quantum can sound complicated, but it's not out of reach. You've just made it through the core of how a quantum processor works. with coffee, with coins, with gloves. If this made your brain happy, hit follow, share it with your nerdy friends, and stay curious, because quantum is just getting started.